Hi, I'm Kel Guerin. I'm the Chief Technology Officer and co-founder of READY Robotics, and we are so excited today on Manufacturing Day to give you a live tour and a live demo, albeit virtual, of our headquarters here in Columbus, Ohio, and talk to you about our extremely exciting new READY Academy, which is really designed to take the power of robotic automation and put it in your hands and make it another tool for everyone out there to create value with robots. So Manufacturing Day is this really exciting event that's really designed to inspire and excite everyone about manufacturing. Manufacturing is absolutely vital to the world right now. Recent events have really made it very important and brought a lot of attention to manufacturing. But this is how we build the things that we use every single day, and it's incredibly important to our future. And so we at READY and all of the companies that are participating in Manufacturing Day are thrilled to have the opportunity to really share our vision for the future of manufacturing and how we can make manufacturing amazing. So first, I just want to give you a little breakdown of the technology platform that we're using. So if you're joining me and you have any questions, we're actually going to do questions at the very end. So in your user interface, you'll actually be able to type in your questions. We've got two amazing guys behind the camera here, Kirk and Eric, and they are going to be either videoing me or monitoring those questions, and then they'll tell me them at the end so we get your feedback, because I really want to make this interactive. If you have any cool ideas or thoughts or questions about stuff that you see here, please let me know, and just jot that down in the question section so that we can answer your question at the very end. So basically, let me give you a rundown of what we're going to be doing today. First, we're going to give you a tour of the READY headquarters here, specifically our research and development lab. And that's really where we build a lot of our technology. And I'll talk about that a lot more. We're also going to do a live demo of our premier product. So what is that? What do we do? So READY Robotics, what we do is we build the technology that is really transforming the manufacturing industry from the standpoint of robotics. Robots have traditionally been extremely hard to use. They're very complex things, they're difficult to program, and we're making software that really makes that process easy so that anyone can start up a robot and learn how to program it in minutes, in few minutes, and actually create real tasks and do real applications with those robots. The key piece of that software is the fact that that software, that easy-to-use software, it works on any robot. We're building underneath that an operating system, which we call Forge OS. And that operating system is poised to do for robots what Microsoft did for computers. Before, in the computer industry, you had a lot of different operating systems. Computers were hard to use. There wasn't sort of a standard way of using them. And not a lot of people use computers. And that really changed in the 80s when you saw operating systems that anybody could learn how to program this computer and then pick up a different computer and it's all the same. And that's our vision too, is you can learn how to program one robot using Forge OS and then go to any other robot and it's exactly the same, which means that now people can just use the robot as another tool. And if they pick a bigger robot or a non-collaborative robot versus a collaborative robot or a faster robot, it's all the same. So that's the technology that we're building at READY. And why we're so excited about READY Academy is the fact that we're going to be able to share that knowledge with you, not only how to program a robot with Forge OS, but also all the other stuff that you're going to need to use to actually put that robot into production. So after our tour of the R&D space, we're going to come back here. I'm going to give you a demo of Forge OS. You're going to see how easy it is to use Forge OS to program a robot. And then we're going to talk a little bit about the READY Academy platform and the content that we've spent a lot of time building so that you can get off the ground and really use robots in a way that you've never been able to before, now that they're easy and now that you have all of the different pieces, not just the robot, but all of the other stuff that it takes to make a robot do what it needs to do in the real world. You'll have all of that at your fingertips with READY Academy. So I think we're ready to start walking here. So I'm going to go this way, and we'll start with our tour of the READY R&D space. So come on with me. So for a lot of you, this is probably the first look at what we do at Ready Robotics. And a lot of what we do at Ready Robotics is build cutting edge technology, because in order for us to really change the manufacturing landscape, we need to think outside the box and redefine what a robot is and how people use it. So right now you're standing in our artificial intelligence test bed. This is a system of robots that is actually learning how to do manufacturing tasks better. Now, when we think about artificial intelligence at Ready, we're thinking about how to empower people. We're thinking about, hey, I may be able to program a robot to do something, but the robot should also be smart too. It should be able to take what I programmed and make it more efficient and better. And that's really the type of technology that we're building from an artificial intelligence standpoint. Is you can make a motion, you can make a program, and then the robot learns how to do what you told it to more efficiently. So it's very user-centric, right? We're all about the user here. We want to make sure that people are really engaged and that robotics continue to be a tool to empower people to do amazing things. So we're walking past another area now where we have a lot of different robots. We call this area Robot Alley. And you'll see a wide variety of robots. I'm going to talk to you about a few of them. But what's important about the robots that we work with is we work with a huge variety of robots. We have a couple of systems from Omron here, the TechMan series robot. These are collaborative robots. And that reason that's important is there are situations where you might want to work alongside a robot for doing a specific task. And these robots don't require any special caging or anything under the right circumstances to be able to actually do those type of tasks. Other robots that we'll talk about have to be behind a cage for safety reasons because they can move heavier things, they can move faster, and they can generally be a lot more efficient under certain circumstances. We have to test both. That's really important to us. And when you go through this tour with us, you're actually going to see a huge diversity of robots. You're probably going to see more different brands of robots in one place than kind of anywhere else outside of maybe an academic institution. We have a huge variety of robots, and there's a really important reason behind that. So let's talk to Jake Huckabee. Jake Huckabee is our VP of Strategic Initiatives. He works with our software a lot. He's going to talk a little bit about why we have so many different brands of robots. Hey, Jake, how you doing?
Good, good. How are you?
Awesome. This is great.
Yeah, so you see we're actually doing testing of ForgeOS right here with a lot of the robots that we've got in our Robot Alley. As I'm sure you mentioned, ForgeOS is cross-platform, kind of like an operating system for robots. Mm-hmm. And the benefit that provides is that really I can learn how to use ForgeOS on my KUKA robot, and then I can come over here to my Yaskawa robot, and I'm going to see exactly the same thing.
Yeah.
All right. So we're focused on making the experience as easy to use as possible. And so we test on lots and lots of different robots, different types, different sizes, collaborative and non-collaborative robots, so that we can make sure that users get really the best performance and the best experience out of the hardware.
Absolutely. Hey, you bring up a really good point, which is for a lot of these systems, because we build an operating system, because we build a piece of software that has to work with a variety of robots, it's very similar to how a company like Google would test Android, right? They come out with a new version of software. They have to test that software on a huge variety of different phones and tablets to make sure that that software works appropriately with those devices. That's one of the main reasons why we have such a diversity of robots here, is because we want to be able to, like Google, test our operating system in as many different robots and as many different circumstances for those robots as possible. And in fact, it's because we're dealing not just with software, but with physical devices, we have to test them in a real world environment. The KUKA is a great example over here. Why don't you talk a little bit about what the big KR210 is doing?
Absolutely. So we've got here the KUKA robot. You can see it's seen a lot of action. But we've programmed it with ForgeOS to go through a number of different motions, different motion types, and really work it around the workspace. And then you can see it's going to come in here, and we're testing the repeatability. We want to make sure that we're getting exactly the same performance that you'd expect from this piece of hardware.
Exactly. Well, and you bring up a really good point, because this robot is actually a used robot, and that's something that we see a lot here at Ready. There's a lot of really cost-effective robots out there. You can find robots like this on eBay and other marketplaces for $10,000, which is a fraction of what it costs new, right? Those robots are sitting there not being used because they're so difficult to program. And so by democratizing that programming, we now enable sort of a new life for a lot of these older systems as well. That was really great. Thank you, Jake.
Thank you.
Yeah. So what's cool about this is not only the fact that we have a lot of different robots that are doing different sort of motions, testing out our software, making sure that the robot works repeatably, but we also do a lot of real world testing. So if you look over here, we actually have a work cell that's set up with some real machine tools, and we're doing real machine tending with it, right? So these systems are a couple of FANUC robots, and the goal here is to actually test the robot with various machine tools. We've got a brand new Haas VF2 here, which is a great machine that a lot of people want to automate with robotics. We've got an older lathe over there that we'll talk about a little bit, but we really want to, from a testing standpoint, make sure that we test our software in as real world environment as possible. And also, when we think about testing, make sure that the robot is doing something that it would be doing when a person programs it, right? This type of machine tending task, where you have a camera, you have a vision system, you have a little alignment tray that the parts actually being placed into, the parts going into the machine's doors are closing. All of that is being controlled through Forge. And that means that when we think about education, we also need to think not just about the programming of the robot, but all of this other stuff that you can program with Forge OS. How do you open the door? How do you open the chuck inside the machine tool? How do you get something from the camera? And to do that, and to provide that knowledge to our customers so that they can feel comfortable using this robotic technology, not just the robot, but everything, we build a lot of documentation, and a lot of that goes into the READY Academy, which we'll talk about later. So this is Jessica, and Jessica is part of our SAW team. They build a lot of our documentation and academy material. And why don't you tell us a little bit about what you're working on?
Hey, Kel. Yeah, so automation is about much more than just the robot itself. So we need to consider how well the robot interacts with machinery in the real world, whether we have a fancy new Haas mill like we see on the right, or an older CNC lathe like we see on the left. And although we love it when customers give us feedback about how well Forge OS works for them in their production environments, we need to test out things as much as we can before we send things out to them. So on our right, we see an older FANUC M20IA robot tending a newer mill. And on that, we can actually use Forge OS to control digital I/O to do things like open and close the machine doors and open and close the pneumatic devices inside, and so on. And on our left, we have a newer FANUC M710 robot tending an older CNC lathe. And on that, we can automate that system with devices like pedal pressers and button pressers and so on. And we covered that in detail in our READY Academy courses, as well as all our other documentation.
That's really great. And you brought up a really great point, which is the fact that you're often going to see this dichotomy in the manufacturing environment. You're going to see somebody who has an older lathe that still works just fine, but it's an older lathe. They buy a brand new robot to work with that. Our software has to accommodate that use case, right? You're going to have people who buy a brand new Haas mill who might have a robot that's used sitting in the corner, not getting any use. And now they can marry the two of those and really make that mill more productive. And they can do that because they're now enabled by that easy to use programming software that we make. Thank you so much. The other great point that Jessica brought up was how we interact with different devices. And as we were talking about, there's a lot of stuff going on in these work cells besides just the robot. So here's Brad. Brad's actually working on a palletizing work cell. Brad, why don't you tell us a little bit about peripherals and how those work with Forge?
Hi, Kel. Yeah, so we're working on a palletizing application, and we're really testing our software's communication with peripheral devices other than the robot. So in this case, we're actually not only controlling the robot, but also a 7th axis lift, sensors, a conveyor belt, and even some safety equipment as well. And so the goal really is to test the limits of our software and peripheral devices it works with, because in the real world, work cells work with a lot more than just robots, right? And our vision is to see someone fluent in Forge OS really be able to work with an entire work cell.
Yeah, that's a really great point. And that's something that we try and emphasize in our course quite a bit, is when we think about all of the different items that go into an industrial work cell. Thank you so much, Brad. That was great. It's not just about the robot. There's a lot of stuff going on here. You've got a sensor that's telling the system that it has a box. You have a conveyor that needs to deliver those boxes to the robot. You have the robot that is picking and placing those boxes with a pneumatic suction gripper, right? All of those things have to work in concert. And in order for those to work in concert, they all need to be programmed by the same thing. And that means that from our standpoint, that same thing, that piece of software that they're using for this entire work cell really needs to be easy to use. So as we keep walking, let's think about how this actually works in the real world, because what's really important about this is making sure that the users who are in manufacturing, the workers, the line workers, the people who previously would have been lifting a box by hand and putting it onto a pallet or putting a piece of metal into a machine tool, they're being empowered by this automation. Because in this situation, because our software is so easy to use, the person who was previously lifting these boxes literally can learn how to program the robot and the rest of the work cell. So now instead of doing one thing by hand, they're controlling a whole fleet of robots that are doing a wide variety of things. And now you've made them more efficient and more productive. They're not going anywhere. In fact, they can't. They have all of the knowledge about how to make this task work. They know how the boxes need to be stacked. They know how the part needs to go into the machine. They have all of that knowledge, and it's up to us to empower them and give robots to them as a tool that they can actually use, rather as something that's, foreign. So that's something that's really important to our mission here. And so the last thing that we'll hit as we walk around is we'll sort of go back to the beginning. This is the READY Academy studio. And this might seem a little out of place for a robotics company, but it was very important to us when we were thinking about how to create content for various robotic applications and for the manufacturing space, that content was really amazing. And it was of the highest production value so that people really could learn as efficiently as possible this material. So we spend a lot of effort making sure you have state-of-the-art equipment, giving you the best video, the best audio that we possibly can, so that your experience in learning this technology is the best it can be. We have cameras that point at the robot, at the screen, so that you can see very clearly what's going on. You can follow along. That's something that's super important to us. So now what I'm going to do is I'm actually going to sit down in front of the, we've got a Yaskawa HC10 here. It's a collaborative robot. It's running Forge as well. And I'm going to sit down and I'm going to show you just a very simple program to build using Forge OS. So we've got our Yaskawa HC10. And I'm going to talk up to that camera now because that's the one that you can see my face. So hide from up there. And so this is a Yaskawa HC10. It's a collaborative robot. That's why I don't have any cages or anything. So it's safe if used under the right circumstances. And then down here, you've got a view of Forge OS where you can actually see me tapping on the screen and making sure that we're getting you a good view. So we're just going to program a fairly simple task with the robot. So let me show you the basics of Forge OS. Forge OS is designed to be a building block-based flowchart. This is something that should be familiar to everyone. A flowchart, you see it everywhere. If you're in manufacturing especially, you see it. But a flowchart is just a very easy way to represent the things that a robot can do. And everything that the robot can do is essentially a building block in that flowchart. So we have our first block here that's just sort of the default block. It just lives there. If I tap on that, I actually get a spot to add another block to the program, right? So if I tap on that, now I have a bunch of different options, right? Well, what are these kind of options? Well, we've got things like robot moves. We've got a variety of ways that we can move the robot. I've got tools that we can turn on and off, like suction, suction on, suction off. That corresponds to this suction gripper that's here on the end of the robot. I've got things like controls that I can have counters, timers. I can make the robot wait for a certain amount of time. There's a bunch of other functionality we're not going to have enough time to get into, but there's a lot of functionality here. And then things like digital I/O, if you're interested in digital I/O, or other communication protocols, and then logic, variables, right? How do I store information in Forge OS and then let you use it in other places, right? So here's what we're going to do. We're going to create just a simple movement. We're just going to move the robot back and forth to start. So I'm just going to click on that block, click move, and then we're going to have the robot go to a waypoint in space, just a position in space. So all I have to do is just hit new. And what the robot's going to do when I select this position, I'm just going to give it a little reference here. When I create this waypoint, the robot's going to remember the spot that it's at. And that is going to be a place that I can then command it to later on. So it's going to be called waypoint 1 here. They just increment up 1, 2, 3, etc. Or I can give it a name myself. All I do is I hit accept. I've got a couple other parameters like how fast I want the robot to go and some other things, but we're just going to leave that default and we're just going to hit accept. Now I've got my block and I can add another block to the flow chart as well. So let's move the robot over to another position. For that, we're going to use the RCP, which is the robot control panel. And what that's designed to do is let me move the robot around very easily. So we're just going to slow it down just a little bit. And then I'm actually going to jog the robot around. And I know which direction the robot's going to go because I have this cute little 3D interface with the arrows that tell me exactly which direction I'm going to move in. So I'm going to move in positive X, move the robot around a little bit. You can see it moving there, just enough so that we can see it moving. And then I'm going to create another move. So I've got my moves, another move, another waypoint move, and then I'm going to go through the same thing. And this interface, this new waypoint interface, you're going to see this everywhere. It's all very easy. It's all the same. It doesn't get different. So I just pick its reference because I want to pick the base of the robot as the reference because the base of the robot doesn't change right now. But you can have other references if you're familiar with that. And again, anything that's confusing at all, just sign up for the course and take it, right? You will learn in detail all of the things that I'm sort of skipping over because of time. So let me hit accept, and then we're good on 10% again, and I'll hit accept again. And now we've got 2 motions that we can move the robot to. Now, I'm actually going to do something now where I want to loop these together, right? I don't want to have the robot just move once, right? Just move to those waypoints once. Robots are designed to do repetitive tasks. It doesn't make very much sense if the robot only does this once, right? So I can actually click on this block and then tap the connect to button, right? And now I just pick the block that I want to connect to. And that's it. That's as simple as that. I've now made a loop that'll just move to these waypoints forever. They'll just until I stop the program. So let me switch the robot into its run mode. And then I'm actually going to execute that program. We're going to speed this up a little bit. I'll hit reset. And now the robot's going to do those motions, right? So now with, in 90 seconds, we programmed a robot to make a very simple set of motions. But fundamentally, it doesn't get much more complicated than this. We'll make this a little bit more interesting, but you're not going to see anything crazy. You're not going to see some new user interface that pops up and is super complicated or anything like that. It's all very much these blocks and the interfaces that let you set the parameters of those blocks. How fast am I moving? Where am I going? All of those things that are sort of common sense, right? So let's let this finish its movement here, and we'll stop it. I'm going to switch back into teach mode so I can add a few more blocks and make this a little bit more interesting. So now what we're going to do is we're actually going to move the robot over to that aluminum block there. So I'm just going to start by modifying this waypoint. So any waypoint I make, I can change. So I just hit modify. And then I'm going to use the RCP and actually move the robot over to that position. So that's a little bit in negative X, a little bit down, slow it down a little bit more. And that's nice. I can change the speed. So if I want to be more precise, I can do that. This robot actually moves pretty fast when you're teaching it. And then I'm going to move so that I'm roughly over the parts here. Get a little bit closer. There we go. That's looking pretty good. Okay, so now we've got our motion. So I'm going to hit accept. And then what I'm going to do is I'm going to take this second motion here, and I'm going to modify that one. And I'm actually going to make this one so that it is in contact with the part. So I'm actually going to jog the robot downwards in Z, right? See the blue arrow going down, so I know which direction it's going to go. I'm going to jog the robot down until the suction cup kisses the part. Why am I not slamming the suction cup down into the part? Well, if you want to learn more about that, sign up for Ready Academy, because I go into all of the details about how to interact with parts with the suction gripper. There's a lot of nuance there, and it's all in our Academy courses. So we're going to just kiss the part there a little bit, hit accept, and now I have my second move. And I can verify that I change those by just going up to our execute menu here and stepping between those two motions. Now, the robot's going to move fairly slow because we have the speed setting all the way down here. If I move it up a little bit, I step again. Now it moves to that second waypoint, so now I'm in contact with the part. Now we're going to add another type of block. We're going to add a tool block. And the tools, again, it's all human readable, right? This is stuff that just you read it and it makes sense. This turns suction on. It's not some line of code. It's just words that you get, right? It says suction on. So we pick suction on. I'm going to step that so it actually grabs the part. And now the robot's grabbing the part. Now I actually want to move back up to that other spot, to that waypoint 1 that we previously created. Well, I don't have to make that again. All I need to do is copy and paste. So I can go down here to this block. I can say copy from, and I just copy the block I want to copy, or tap the block I want to copy. And now I have that next block. I hit step. Now the robot lifts up a little bit to actually grab the part. Now, something that's important to note about this is you may not get things perfectly right the first time. Robotics takes a lot of trial and error, and that means that you really want a good user interface that can support the fact that you may have to change things a lot, right? You may have to iterate. You may have to start with a program and make it more complicated and then change things again, right? Really combine all of your skills about the actual task, and the piece of software needs to keep up, right? So it's very easy to change things, easy to modify things. I'm looking at this where the robot is right now and actually thinking it'd be a little higher. Well, that's waypoint 1. We created that. All I need to do is modify it, right? I can go here. I can go to modify. I'm going to lift up the robot a little bit. Move it to -Z up to there. I like that a lot better. Come back here, hit accept. It asks me if I want to modify all of the versions of waypoint 1. That's what I want to do because I want it to change everywhere. I hit modify all. We're good to go, right? So now if I step through this again, robot's going to go down to where the part was, turn suction on. It's already on, so we don't see anything, and then move back up to that point. So now what we're going to do is move to another spot and set the part down. So I'm going to, again, go to robot move. And let's do a different move this time. Let's do a blend move. So this is a move where I actually have more than one spot that the robot is going to go in the same move, and it'll move along sort of a curved or a jagged path, depending on how you set it up, to actually get there. So let's create another motion that the robot's going to move to. So we'll just hit new, and we'll move the robot in +Z so that we're over there a little bit. That's looking good. Okay, so let me move it a little bit towards me, so that's +X. There, that's a good spot. Gonna set the reference point as the base of the robot, hit accept, and now I've got my waypoint 3 there, where the robot currently is. Let's add another one. So again, just go to new. It's the same thing over and over again, right? It's not anything new. It's not anything hard. I'm going to go, let's see, -Y a little bit. We're going to try and put it down in spot 3. And now we're going to actually go down a little bit so that we can get it a little bit more precise. And in this situation, I'm actually going to slow down the robot even further so that I can very precisely position the part. Now let's check and see that that is where I want it to go, and I'm not hitting anything. That's looking pretty good. Yeah, that's looking great. All right, so, but we still want the spot above where we're going to set the part down. You hit accept. We got our waypoint there. And now we're going to actually add the part where the waypoint where it sets down the part. Same blend move. It'll all be one continuous motion. Hit new. Again, now we're going to jog down the part. I'm not going to put it all the way down because that suction cup is going to expand as it opens up. So we don't want to just mash the part down into the metal. We want to give the suction cup room to expand. Something, again, we talk about in the academy courses. And that's it. And now I'm going to let go of the robot, or let go of the part. I'm just going to have, again, tools. I'm going to hit suction off. So now the robot's going to let go. So we just step that. There's the part. Suction cup looks good. Part looks like it's in the right spot. Everything looks happy. And then we're going to move the robot back up a little bit. Now, I'm actually going to use a different move to move the robot back up. I'm going to use a jump move. And this is really great because a jump move moves relative to where you currently are. Instead of a fixed position in place, it goes from where you currently are in space, right? So right now I'm sitting there. I actually just want to move up, which is going to be in the negative Z direction. So I tap the field next to Z. Let's move it 3 inches and in the negative direction because we want it to go upwards. And that's it. I've got same parameters, speed. If you have a force sensor, we can deal with that. But we don't, so we'll just hit accept. And now I can step this and the robot will very slowly, because we have the speed set super slow, jump up 3 inches. Actually, I'll stop it and run it again just so we move at full speed there. Perfect. So now we've got our basic pick and place that we can run. So I'll put the part back where it was before, roughly centered so I don't mess it up. All right. And now we'll just move, we'll step to waypoint 1 just to make sure that the part is where I think it is before we run. And this type of stepping through your program is very useful because it lets you validate exactly what you programmed. And actually, I was a little bit off, so I need to move the part just a bit, right? There we go. That's where I programmed it, so I need to make sure the part goes back to that spot. That's something else that we talk about. When we talk about the robot in the Academy courses, when we talk about the robot, we talk about its ability to interact with objects. Those objects need to be in the same place every time, right? The robot is a very repeatable device, but it's not super intelligent. It doesn't know if your part shifted a little bit. So how do you do that? Well, there's ways to do that mechanically. There's ways to prepare a part and drop it into a line fixture so that you know that it's in exactly the same point every time. That's what was going on with the Haas mill over there, right? All of these strategies for how to actually get the robot to manipulate parts properly so that you can precisely do tasks all of that is in the Ready Academy courses. So this looks good. So let me switch into run mode. Come on. There we go. Reset the task. And we're just going to do this in a loop. And actually, that brings up a great point. So because this is a loop, we want to actually make sure, because I have to put that part back, we actually want to make sure that the robot pauses in between finishing and starting again, because it needs me to put the part back. So what I can do is I can actually put another block in here. We'll go to control and we'll go to a user action. And what this is going to do is it's going to prompt me, the user, whoever is standing in front of the robot, to actually do some action, right? And in this case, it's refill. So I'm just going to say refill, hit accept. And now it's going to pause before continuing. So let's run this task and see how we did. We'll see if I got it right on the first try. So we go down, we pick up the part, we make that continuous motion so that the part actually goes in. You saw how nice and smooth that was. And then we drop the part, and then I have another user. I have my block here that says, hey, you need to continue, right? Right now it says path bottom because that's the path that'll go back up to the top and restart. You can rename these whatever you want. We'll stop there because that's sort of the end of the demo, but you can see how easy this is. And we programmed a fairly simple pick and place task, but I guarantee you that this is one of the easiest ways to program this robot, specifically to program this task. And once you've learned how to do this, it doesn't get any harder. Even though you're going to program a more complex task, even though you're going to program different things that the robot will do, interact with more parts, etc., it's going to stay this easy. And then when you walk over to a different robot that's also running Forge OS, it's going to be the same. It's exactly the same user interface. Even though the robot's 10 times bigger or this big, it doesn't matter. Collaborative, non-collaborative, it's all going to be the same user interface. So now what we're going to do is we're going to switch cameras again, and we're going to talk a little bit more about the actual Ready Academy site and the course material there. And we're going to start with a video of our software, our Academy course actually being implemented at a really exciting place that we partnership, which is the East Kentucky Advanced Manufacturing Facility. They're a Haas Technology Center, and they really provide an incredible curriculum for upskilling people who have never done any kind of manufacturing stuff. So the Haas curriculum teaches them how to be really amazing machinists and operating the types of machine tools that you saw. And then we actually piloted the READY Academy course that you're going to be able to take for free. We piloted that with them on top of their education with the Haas machine tools that they were working with, so that they now were able to program robotic automation. And we took people that had never used a robot before, that never even seen a robot before in real life, and in a week and a half, they were using that robot, and in 2.5 weeks, they were programming lights out applications. What does that mean? It means that they were running the machine overnight. They had a robot sitting there by itself with a Haas mill, actually putting parts into it and taking them out. Nobody was there. The robot was doing all of the work, which is something that's very difficult and incredible. And the fact that they were able to do that so rapidly was because the course that we delivered there very quickly taught them how to program the robot in just a couple of days. The rest of the course focused on everything else you had to do. Where do the parts come from? How do they go into the machine? How do I hold them? How do I make sure that that process is reliable enough that I can walk away and turn the lights off and go to bed knowing that I can walk in the morning and I have more parts, right? That's something that was really incredible. It was an incredible success of that institution and our software in that environment. So please enjoy this video. The people down there were absolutely incredible. It's super inspiring what they were able to do once this software, once programming robots was really easy and accessible. So why the opportunity at eCami is so exciting to us. The students here just received this amazing background in CNC technology. Those are exactly the type of people that should also have robotics experience. With our software, they can learn it once in a couple of weeks and then be able to transplant that skill set to any robot that they use. The students here who now are CNC experts are also experts in using a robot to tend those CNC machine tools. That type of skill set would take months with any other technology platform. And with the education that they received here and the power of Forge OS, we did it in 16 days.
No, 10 years ago, I didn't think I'd be doing any of this. I've learned in CNC machining that, you're only limited to what you can think of. Being able to program a Haas machine to do what you need it to do, and then go back to Forge OS to tell the robot what to do and have the robot and the machine work together has been just phenomenal. By being a student here, you learn to be adaptable and flexible. The robotics course that they're learning here, we know that there's other robots out there, but by being familiar with just a few collaborative robots, that would give them the mindset on, hey, I've done this before when I was a student at eCami, and I can take that moving forward and just improve. I would say within a couple hours of robot time, I was doing it. Now I'm at the point where I think of what am I going to do next? What am I going to create now?
My previous job was a customer service desk associate at Lowe's. I wanted a different career path, one that was more hands-on, and once we got on the machines, it was just, I loved it. I have fun with it, I enjoy it, but I'd never seen robots like this until READY visited us. I think they're super cool. I love it. I really did at first think that it was going to be harder than it was with the Forge system. It's been a lot easier than I thought it was going to be to program Forge and to run the robots and stuff. For me, it's seeing the progress that you make. So, starting out our first week, we learned how to move from point A to point B, short distances. And now here we are, and we just ran our first lots out production and ran it smoothly, and everything went good. Ran 30 parts. Whether you have some knowledge or whether you have zero knowledge with robotics, anyone can come in and be taught easily how to run the robots.
I'm a former coal miner, worked at Perry County Coal. I was an underground electrician. I came here to eCami to keep on doing the same thing I've always done, advance myself. and further my career. It's difficult at first, but and as far as the robotics part, he's made it so simple that someone like me who's not real savvy in computers, it's very easy for me to adapt to it real quickly.
I really thought that it was going to be very difficult because there was different brands of robots, and I didn't understand that the forge controller never changed throughout the robots, and that was a big help because once we learned how to program this robot, you can do it on any robot. And the way that they've structured it with its flow chart and how you can organize it, it makes it very easy to understand where you're at in your program and organize it and let it run smooth.
Awesome. I have to say, I was watching the video out of the corner of my eye again, and it's so inspiring because what these people were able to do, the students at ECAMI, just because, you know, they came from a variety of different backgrounds, you know, people who worked in the coal mining industry, people who were, you know, working at Lowe's, right? For them to be able to now participate in manufacturing, that's something that's so important. It's really the point of this whole day, is being able to draw more people into manufacturing. We know that manufacturing is important. I've said that before, right? But there's not enough people who are in the manufacturing space right now. It's called the skills gap. It's something that, you know, people are retiring, people are leaving the manufacturing space, and that means that there aren't enough people who know how to do the things that we do to build the stuff that we use every day. Automation is a huge part of that. Being able to provide automation and make people more valuable and able to do more things and build more stuff, that's super important. But there's a skills gap in automation too, right? So being able to have people who came from a variety of different backgrounds not only learn the essences of manufacturing with Haas and the machine tools that they had there, but also learn how to use robots to make those machine tools as efficient as possible, to really make the robot a tool to make them more productive as individuals, is something that's it's incredible. And we were so proud to do that. And the whole point of READY Academy is really designed to give every single one of you out there who sign up for READY Academy that same empowerment. Anybody should be able to program an industrial robot. I'm talking about the robots that you've seen here, real systems that work in real manufacturing tasks that can change the world. And we want to enable every single one of you to do that with our READY Academy course. So we're just going to go through the course a little bit. This is what you're actually going to see when you sign up for READY Academy. And again, I have to emphasize, this is for anyone. You don't need to be an engineer. You don't need to be a computer scientist. You could be anyone, literally anyone. But think about how you could participate in the world of manufacturing and solve the really hard, challenging problems that are out there if you had this skill set. And with READY Academy, you now will be able to program robots and use them to do real manufacturing tasks. That's what's so exciting about this. So let's dive into the Academy itself and actually look at some of the courses there. Essentially, what you're going to see when you go to the READY Academy site is you're going to have all of the different courses that we offer. And this span a wide variety of different robotic applications. Everything from the history of robotics. If you don't even know what a robot is, except for what you've seen in television, right, or movies, go watch that video because it's an incredible introduction into how robots are used every single day and how robots touch a lot of the things that we use every single day. Something that's really exciting is the understanding how the robot industry works, the different types of robots that are out there, different form factors. Most of the robots that you saw here are 6 degree of freedom arms, right, that lift stuff and pick stuff up. There's a lot of other differently shaped and differently capable robots that can move blazingly fast or lift cars or maneuver tiny little objects or work with food-safe things. Like you want a robot that can move cookies around at high speed. We talk about those kind of robots. So we really dig into the applications to give you a background about what robots are used for and how you could potentially think about using robots in your production environment, in your business. Maybe if you're not in manufacturing at all and you want to get in, you want to think about that, this is a way for you to think about where you would want to go. We also talk about the basics of robots. So when we think about what a robot is and how it moves, how it represents its position in space, all of the things that I worked with when I talked about the Yaskawa, how does it measure its position? How do you know that it remembered that specific position as opposed to somewhere else? What's the reference frame that it's knowing that position in? All of that stuff may sound complicated, but it's not. And in this course, we teach you all of those essential skills so that you could look at any robot, no matter if it's this big or gigantic like the KUKA, and know exactly how it's moving, how it represents its position in space, and how you can put it to work. And that's really what's important, is putting those robots to work. So if you look at some of our other course material, we talk a lot about peripherals. For instance, safety devices. So a lot of safety devices are necessary for these larger robots that have to be in a cage with other devices. That's something that we take very seriously at READY, is the safety of these systems. And we give you a huge amount of content by our own Jake Huckabee that you met, who is an expert in robot safety, really a deep look into the type of safety aspects of robotics that you need to understand to put these things into production. Something else that we look at a lot is actually the what else you need to have in your work cell, whether it's peripherals or vision systems, any of that, right? When you think about what we were talking about, these work cells, we weren't just talking about the robot. You've got the thing that turns the lathe on so that it actually makes the part, whether that's a pneumatic button presser or it's something that pushes the pedal of the lathe, right? Where do the parts come from? Well, there has to be a rack or some kind of drawer system or some kind of set of pins that the parts come from so that they can actually be put into the machine, right? All of those different aspects, where the parts come from, how they're held by the robot, how they go into the machine, how you design gripper fingers, right? That's a huge part of our curriculum, is how you actually design the fingers that interact with parts. We have one of our partners, Shunk, who actually developed a course specifically about how to design fingers for robots, which is an incredible resource because that's really where the rubber meets the road, is how the robot holds the part and is able to move around at high speed with precision to be able to do the task. So we really touch on all of these different aspects. We also talk a lot about efficiency. We talk a lot about once you have your robot program, you've spent a lot of time setting this up so that the robot does the thing and does it repeatably. How do you make that as efficient as possible? How do you make that reliable so that, like the folks at eCami, you can walk away at the end of the night and let that robot run overnight and know that it will work 100% and come back in the morning to a bunch of parts that you made with lights out, right? Building a program and programming the robot and thinking about all the different parts of the work cell so that you have that type of reliability so that you can count on that system so that there's no variability at all. That's something that we talk about a lot. And we also talk about the business aspects of that. How do you get the best return on investment of the robotic system you put in place? How do you tweak your process so that you get more parts out of your production process and make more money? That's the whole point of putting in automation, is so that you as a manufacturer or as someone who works for a manufacturer can be more efficient. The robots can produce more parts, help you break bottlenecks in your production process, and really be another tool, right? And that's really what the Academy is about, is robots are an essential tool to manufacturing. But it's a tool that hasn't really been accessible until now. It's taken a huge amount of work and knowledge and time for people to learn how to use a robot. So I really encourage you to sign up for READY Academy. It's completely free for individuals. If you're watching this and you're a larger organization like an educational institution, a larger company, please reach out to us. We are happy to connect you and offer it to you guys. This is an essential piece of knowledge that we've created here that really allows you to leverage robotic automation in a way that hasn't been possible before, because now it's actually easy. It's actually accessible. And once you learn it, you can transfer that knowledge to any robot. You don't have to go learn it again if you decide to pick a robot that's a different color or a different size, or that's collaborative versus non-collaborative, right? You can pick and choose the robot you need, and you have the skill set that you know that when you get that robot in the door, put Forge on it, and it's just the same as it was before, right? It's the same as everything else. So that's why we're really excited about this course. Again, go to ready.academy. That's the website. Sign up there for the course. You can very easily pick and choose which courses you want or take the whole thing. It's about 40 hours of content. A really amazing team of people here at Ready spent 2 solid months of their lives putting this together and making sure that it was the highest quality and the most informative robotics course that anybody has ever produced. It's really incredible, and it's free. So please go to ready.academy, sign up. We're super excited about it. And then just maybe when you take those courses and empower yourself with robotics, you'll be able to play with a lot of the things that we've looked at today. You'll be able to buy a robot and use it with Forge OS and make your business or yourself more productive.